Hi everyone. This time we're looking at chromatography, in particular the chromatography of the colours in sweets. Now you'll need a couple of sweets. Green Skittles seem to be the best, but you can use another one if you want. You will also need a container with some clean water, a pencil and a pair of scissors. A pasteur pipette will be useful but is not essential. When it comes to applying the colours to the paper, you need something to be able to get a small spot. You could use the pencil tip perhaps, or maybe a cocktail stick. I'm actually going to be using a wooden skewer. The first thing we'll do is set about extracting the colour from the Skittles. So what we do is we open one universal, drop 2 Skittles in and put in a small amount of water. You don't need to measure it, but you do want to make sure it's a very small amount to get the most concentrated colour you can. Don't put in enough to cover the sweets. You can just shake it around so it washes over both of them. So we'll put that to one side for a few minutes and prepare the paper. You take the scissors and cut yourself a strip of paper. Try to make sure it's reasonably wide, but not so wide it won't fit inside your universal. That should be okay. We'll have a look. Yes, that's fine. I'll just trim it a bit. So now you need to make a pencil mark about 1 centimetre or so from the bottom of the paper. This will let you know whereabouts you have to put the colour. Now for the colour. You can see we have a decent amount of colour in solution, and the sweets themselves are pretty much white. So what we do is we apply a small amount to the paper, but only a small amount. Now, as I said, I'm going to be using this wooden skewer. All I'm going to do is to dip it in and then dab it onto the paper. As you can see, there's a blob of colour. It's not very much, so it's best to let it dry if you can. Either blow on it or use a hairdryer to speed it up if you want. Then you can see about adding 2 or 3 more droplets. The more you add, the more intense the colour, and so the better the separation will be. But your patience may not stretch that far. If you're using a pasteur pipette, that's okay. Don't squeeze it, you just touch it very gently onto the surface of the liquid and then dab it onto the paper. The smaller the blob, the better the separation. Now this one's not going to be perfect, but we'll leave it at that. Now what you want to do is to put a very small amount of water in the bottom of your other universal. You can see the bottom's got a conical depression, so you want to fill it to no more than the top of that. That'll be plenty. So now what we're going to do is we're going to get our piece of paper with the blob of colour on it and gently drop it in, place it in. It may well settle down into the water a little bit as it loses its strength as getting wet, but hopefully the blob of colour should stay above the water level. Now you should see very soon that the liquid starts to go up the paper by capillary action. You see mine's got to about here already, and in a little while you should see the colour starting to separate. Where you did have a single green blob, you should now see it going blue at the top and yellow at the bottom. Anyway, we'll leave this for a few minutes. Right, well, once the water has got a significant way up the paper, it will start off quite quick and then slow down. You can then stop. You can see here it's got to round about there, and what you can see is around about here there is a section of blue where it has the blue dye has travelled, and down there, hardly moved at all, is the yellow. It's smeared out a bit but hardly moved at all. So you can clearly see that it has separated out the 2 colours. And what you do is you take the piece of paper out and you put it down on there. So you can see here the reason you mark the paper, that's the distance the dye went to, the water went to, and you can see that you've got a clear blue bit here and then there's a yellow bit here, so it's separated out. The green was made up of blue and yellow. Now the reason for marking this is you can measure the distance from here to here, and you can measure how far the liquid travelled up, the colour travelled up the paper. So if you measure that distance and divide it by that distance, you get a figure which is smaller than 1, and this is called the R value. That's got quite a large one, this has got quite a small one. If you get 2 blue dyes and they have the same R value, as long as they're in the same solvent, then they are very likely the same blue chemical. If they have different R values, they are almost certainly different ones. There are obvious exceptions, but they're almost certainly different ones. So you can actually find out whether or not a particular blue paint is the same as another blue paint. And this can be quite a useful analytical tool. In reality though, this sort of analysis is usually carried out by thin layer chromatography, which is the subject of another video.